Hello and welcome to another exciting video here in Mathland. We are in chapter 9, lesson 9.7. This is the last lesson of this chapter. So exciting. Probability. Okay, so you probably have heard of probability before. Probably, right? Probably. Or in a previous math course. Where we talked about events and outcomes and sample spaces and all that fun stuff. Oh, and experiment. So all these are new vocabulary words. You can read along on page 746 about experiments and outcomes and sample spaces. Okay, so experiment, you probably understand what an experiment is, given the math courses you've been through, or not math courses, science courses you've been through so far. Something happens there. The possible results of an experiment is what? The outcome, right? Are all outcomes there. And the set of all possible outcomes of the experiment is the sample space. And then if you want to do something specific or looking for some specific solution or outcome of something, you're looking for an event. Okay, so let's go ahead and find sample space. We're going to work through example 1 here with our sample space. I'm going to get it up here on my paper. So it says find the sample space for each of the following. So I've got a coin right here. One coin is tossed. Okay, here's my coin. I've got heads and I toss it on the book. And I've got tails. Okay, so one coin is tossed. So my options for A, what is my sample space? My sample space is all possible outcomes here. So it's not going to land on the edge. Don't be sneaky or clever about this. It's only going to land on one side or the other. So I only have two options, right? So I have two options. I'm going to put that down just so I know how many I should have for my sample space. So what are they? I'm going to use my cool little brace here and say, oh, it's going to be heads or it's going to be tails. Okay, so my sample space is this. This is it right here. Heads or tails. Okay, two coins are tossed. Okay, so let's look at B. How many options is that? Okay, so let's go back to our the last section where we talked about counting principles and permutations and combinations. So I have two coins. Boop, boop, two coins here. So how many options do I have for one coin? I have two, right? How many options do I have for the second coin? I have heads and tails. And for the other one, I have heads and tails. So I have heads and tails and heads and tails, right? So I'm going to use this as a guide to help me when I list the sample space for all of these options here. So I should have 4. Okay, so I want to keep that in mind as I'm listing my sample space. Okay, so let's go. So I've got, let's do heads, heads. Let's do tails, tails. Let's do heads, tails, and tails, heads. Okay, so this is my entire sample space. Yeah, you gotta write them out, but that's it. So sample space, using what we learned in the last section here, as far as the counting principles, use this as a guide to let you know how many you should have in the sample space here. So I had 2 options for the first one, 2 options for the second one. I multiplied them and I got 4. Okay, so I should have 4 over there. C, what's C asking for? 3 coins are tossed. So again, I'm going to put my little line here. Boop, this is my first coin. Boop, this is my second coin. Boop, this is my third coin. So I have heads, tails, options. I have 2 options there. I have heads, tails, options. 2 options there. And I have heads, tails, options. 2 options there. So how many sample space or things in our sample space should we have? 2 times 2 times 2. So we should have 8. Okay, so keep that in mind when we're making our sample space here. So I've got all these guys, only I've got another coin added on to it, right? So let me move this up a bit here. And we're going to list all of our little things in our sample space. So let's start with heads, 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 tails. Let's see, heads, tail, heads. Okay, so that's 3. We've got 5 more to go. All right, so then we have, let's see, tails, heads, heads. Oh, we didn't go tails, tips, tails, tails, tails. We've got heads, tails, tails. There we go. 1, 2, 3, 4, 5, 6. 2 more. Can we figure them out? T, H, tails, tails. Oh, wait, no, tails, tails, heads. Oops, I got that one. And then we have tails, heads, tails. Okay. We know we have all of them because we should have 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. That looks like a F. Okay, ta-da! All of our sample space right there. That is the answer for part C right here. Okay, next we're going to move on to probability of an event. Okay, so probability is where we have our event over our total outcome, and that becomes the probability. So how many outcomes of the specific event over the outcomes in the sample space. All right, so let's get down to an example here. Let's see, oops. We've got, let's use this down here. So we've got a coin. 2 coins are tossed. So right here, I'm looking at example 2, part A. 2 coins are tossed. What is the probability that both land heads up? Oh, again with the coins. Okay, so 2 coins are tossed. We have heads or tails. All right, that's for one of them. Remember, we have 2 coins. So we have heads, tails, 2 times 2. So we should have a total of 4 in our sample space, right? We already did that with the what sample spaces that we had in example 1. So I'm going to pull out what I had before with the 2 coins that were tossed. I had 4 outcomes, and it says, what is the probability that both land heads up? Heads up. So heads, heads. Boop. There we go. Heads, heads. So 1 out of 4. That is our probability. We have 1 out of 4. Da, 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 da. That's our probability. So if you want to be all official, you can say, ooh, well, I've got the probability of this event is 1/4. Always reduce when we have our probabilities. So we always reduce fractions, whether it's in a probability fraction or otherwise, or reduce. Okay, so now that was A. Let's do B on example 2. A card is drawn from a standard deck of playing cards. What is the probability that it is an ace? An ace. Okay, so how many cards are in a deck? If you don't know this, you should know it now because you're going to have to deal with card questions here. So there are 52 cards in a deck. Okay, so what if it's an ace? Okay, so we have how many different suits? We have 4 suits, and each of them have an ace, right? So we have 4 aces in the entire card deck here of 52 cards. So let's see, let's put this all together. Our total sample space of cards is 52. And how many aces? We're looking for aces specifically. How many aces do we have? We have 4. 4 out of 52. Let's reduce that. So it's going to be 1/13. Ta-da! There we go. 1/13 for this probability. Oh, and look, we got them right. Hey, how about that? Okay, next page. All right, so let's take a gander at example number 3, finding the probability of an event. 2 6-sided dice are tossed. What is the probability that the total of the 2 dice is 7? Okay, so let's see what we have here. Oh, don't look at the answer. We're going to work it out on our own. Okay, we have 2 die. We have the numbers 1, 2, 3, 4, 5, 6 on one, and we have 1, 2, 3, 4, 5, 6 on the other. Okay, so we got to find out the total of 2 dice is 7. Okay, so we can put 1 plus 6. So let's do. If this is the first, let me start over. So first, I roll a 1, and the second, I'm going to roll, it has to be 7, so sum of 7. So if I roll a 6 in the second one, that equals 7, right? So if I add these up, now what if I roll a 2 in the first one? I have to roll a 5 in the next one. That's 7. Okay, good. 3 in the first one, and we got to get, 4 in the next one? Okay, 5 on the first one, and then 2 on the second one. And then we can do 6 on the first one and 1 on the 7th. That equals 7. Okay, and we also have, oh, I forgot, let's see, 3, 4. Oh, I didn't do 4. 4 plus 3. He was supposed to go right there. Equals 7. Okay, so 1, 2, 3, 4, 5, 6. All right, so we have all of ours. Sometimes you forget one. You have to go back and see what you have. Okay, so we have 1, 2, 3, 4, 5, 6. 6 possible rolls that we can get with the first and second. Okay, so we've got six rolls, okay, to have a sum of 7. sum of 7 okay, and 6 over the total number of outcomes. I don't know if you know this, but if you're going to roll 2 die, think about it. How many possible outcomes are we going to have? There's 1 die and 2 die. So the possible outcomes that we can have for 1 die is 6, right? We have 1 through 6 on the die here. And our other possible outcomes for the second die is 6 as well, because we have 1 through 6 on each side. Okay, so 6 times 6, that's going to be a total of 36. So this is our total outcomes. And then for this specific event, we have 6. So we have 6 outcomes for this event over our total number of outcomes, which is 6 over 36, which reduces to 1 over 6. Ta-da! Yay! We did it. Okay, so looking at the dice, crazy stuff here. So total outcomes for 2 dice is 36, just FYI. You might see it in your homework. Total outcomes for 1 die is 6, because each side, there are 6 sides, each side has a number. Okay, next example. All right, this last example is just proving the same probability for a 12-sided die, which everyone has at home, right? A regular dodecahedron. Okay, so this one I'm just going to walk through this one because they're going to have the same probability as the other one. And so it says that, let's see, prove that these dice can be used in any game requiring ordinary 6-sided dice without changing the probabilities of different outcomes. Okay, so they're saying, hey, what if you have a dodecahedron instead of a cube? Well, you can use the same thing and you'll get the same probability from these numbers. So it says for any ordinary 6-sided die, each of the numbers 1 through 6 occurs only once. So the probability of any particular number coming up is 1 out of 6, which we figured out on the last one. Okay, well, sort of on the last one. We figured out a combination of 2 die. And then for a 12-sided die, each number occurs twice, so the probability of any particular number coming up is 2 over 12, which is 1/6. Oh, yeah, look at that. It's the same thing. All right, well, those are all the examples I have for you here. The homework just has listing sample space, which is all that stuff like the heads, tails. So this is sample space listing. And then it goes into probability, which was figuring out the total number of outcomes and the outcomes of your particular event. So that's all the homework is for this one, and this is about how far we will go in section 9.7. Ta-da! All done.